Hello everybody! As developers, we are all robots, right? And we remember every guideline, convention, etc. This is Stef from Samayas, and welcome to my channel. You guys might be perfect, but me personally, I mess up quite a lot. Okay, I do try to follow and create guidelines and structure all my projects in the same way. May that be for my personal project. There it's a little bit easier because I'm in control. However, when we're working on corporate projects with 5, 10, 20 or more people, there it becomes a little bit more harder. Plus, in general, there's a lot of people turnover. That makes things even more complicated. Of course, each project is different, but then again, loads of things are still the same. The code and the right way to write it. First, of course, we have Visual Studio editor settings. Do we really need this as a prefix, or don't we? Are variables starting with an underscore or not? Where are the brackets placed? And where should the white spaces be? Should we use tab or white spaces? Well, thanks to Visual Studio editor settings, we can configure this and share this amongst the team. However, everybody prefers its own style. And for this one, there isn't really a solution. Choices have to be made. On every code check-in, if the first dev checks in some code with a specific layout, and a second dev just changes the layout, that isn't really an option. That triggers git changes, which are not really code changes, and that makes a mess, of course. So that's not really acceptable. Next, of course, we do have ReSharper, which is the big one to reshape and align code looks. There are, of course, other tools like CodeRush, Visual Assist, StyleCop, Sonolint, etc. Of course, these tools do more than just reshape the code. And then, if you want to impose other things, more specific, for a project or a type, a class or a method, we do have Roslyn and the .NET analyzers. Some examples are forcing class naming. Say you have a view model that inherits from a base view model, and you want to impose that the class ends with view model, or your entity or model classes that need to end with entity or model class name, or for your entity classes that you absolutely need to have a default constructor for serialization, or some test method that needs to end with success or failed, or that you can exclude from code coverage. The possibilities are endless. So today, I'll dig into building your own custom Roslyn analyzer. So let's start Visual Studio, and let's create a new analyzer project. In the Create Wizard type Analyzer, and then we'll choose the analyzer with code fix in .NET Standard. Choose Next, and here you need to enter a number of project settings. First the project name, then the directory. Then I need to choose the directory name where I'm going to create my analyzer in. I can choose a different solution name from the project name. I can place my solution and project in the same directory. And then finally, something which is very tricky is we can choose which .NET version we can use. However, once you have created the analyzer, in essence, it creates first an analyzer project, then it creates a fixer project, then it creates a package project, next it creates a test project, and finally it creates a V6 project. And this setting only applies on the V6 project. So for now, I'll leave it like this. I choose Create. And so we have successfully created our analyzer. So as you can see, our wizard created 5 individual libraries. The first of the 5 is the Analyzer library. This is where you will write your Roslyn analyzers to analyze your code. As you can see in the settings, the analyzer is .NET Standard 2.0. If you look at the dummy analyzer that has been created, the goal here is to take each of the name types, that means class name, method name, etc., and provide a warning if some of the characters are in lower. And so in essence, the goal of this analyzer is to change all your classes method names to all caps upper. Of course, this is just a demo code to prove what is possible. The next class, which is the code fixer, fixes code. And depending on the type of analyzers you have, you might try to fix the code yourself. And in this scenario, it's very easy. Whenever any of your class names or method names have a lowered char, it will adjust to upper all and then replace the method name or the class name. If you go to the code fix project, again, we have a project which is in .NET Standard 2.0. Of course, there will be scenarios where you have analyzers which analyze complex settings you have invented yourself, which you can pinpoint there's an issue, but where you might not necessarily be able to provide a correct fix. And so you might have analyzers without code fixers. The next library is our package. And the goal of this library is just to create a NuGet package, which is composed of your analyzer and your code fix. As you can see, there's an install power script and an uninstall power script. And our NuGet package has a number of settings that you need to update or remove, like repo URL, package URL, license, etc. Preferences, the analyzer and the code fixer, and it stores those libraries in analyzer.NET CS. So if you want to do the same thing for VB, you will have to modify it, create different libraries, and handle the VB part. The next project is our test project. If you go to the settings here, so as you can see, out of the box, this project is still in .NET Core 3.1, but we can upgrade it to .NET 9, which is a .NET Core version, and it's not the old .NET Framework nor .NET Standard, but this is just for the unit tests. And then finally we have our Visual Studio V6 project, or Visual Studio extension, with a V6 manifest, wherein we can clearly see that we have the analyzer defined, and where it takes all necessary analyzer components, and where it installs it for everything which is Visual Studio 15 and upwards. If you install it as a V6 component, it's applied for every and all projects, whatever you do. If you go to project settings here, this is the only one which is in .NET Framework 4.7.2, which is what the wizard asked. The wizard didn't ask if you want to change your test settings, project, and the analyzer, the code fix, and the packages have to stay in .NET Standard too. So that's quite tricky. So how can we use it now? Well, on one side, we have a NuGet package. On the other side, we have a V6. But before we want to start playing around, we better use an experimental quote-unquote version of Visual Studio. For that, Visual Studio has a specific key, which is called root suffix. And so in order to start that, you just open up a command prompt, you enter the path where your Visual Studio devenv is located, you enter /root suffix, and you enter a specific key. In general, they use experimental, but you can use whatever you want. Say you have different needs for different developments, well, you can just specify analyzer 1, 2, 3, etc. Here, I've just specified analyzer. Let's start it up. And so now we go again through the setup process of Visual Studio. Since it's thinking it's setting up from scratch, let's choose maybe later. And it opened a second Visual Studio. And here you can clearly see analyzer. So we're running in an analyzer version. So before I do anything, in this Visual Studio, I will first create a test project. Just a simple library. I will create a class library and I'll call it Analyzer Test Library. And so now we have a playground where we can play around with. So under our test library, under dependencies, we have analyzers, and there we have all the analyzers which are currently active. If you click on one of the Microsoft analyzers and we open it up, there are all the keys for all the analyzers which is running on your code, which you can activate or deactivate, change the severity if you want. And so our new analyzer will be added here as well. Scenario, we're going to take our NuGet package and we're going to add it. Now, if you're a normal project and you've created your NuGet package and you deployed it to NuGet or to your private NuGet store, you just need to do add manage NuGet to browse, type here your analyzer, and you will find it. However, in this scenario, we have just a NuGet on our machine and we need it to find that NuGet package. So somehow we need to be able to add that package to our other solution. So somehow we need to be able to add the package, which is located here, to our test project. So we copy the path, we go back to our second Visual Studio, and so here under package sources, we click settings, and we're going to add a local package source. So we will paste the path we just copied, and we call it NuGet Analyzer. We click OK. And so after having added it, we go to NuGet Analyzer, and as we can see, we have our first analyzer. And the only thing we need to do is install. And as you can see, he automatically added our analyzer, the first analyzer, and our CodeFix DLL, which doesn't contain anything, but which is added as well. Well, you can see we have our analyzer 1, which complains that all class methods should be to upper, because it contains lower. If we click on the little light bulb, we have a second thing, make upper. And so now our analyzer is gone, and we have a perfectly working analyzer. Now let's remove this NuGet and return to the V6. And so as you can see, if I open up the project, we just have a package reference, which is called Analyzer1 with version 1.0. And that's the only thing that happens in your project file. And our analyzers are gone. Let's revert this to again class 1, and we're back to square one. If we have a look at our V6 directory in the bin debug, here we see we have a V6 file. Since the project is already called analyzer1.v6, there's still an extension added .v6. And so if you want clearer naming, you need to rename the project. Your v6 command, and you've installed it in the Visual Studio library, the way to do it would be going to Manage Extensions. And here you could just do Browse, enter your v6 library, and then just click Install. However, we're still in development, so it's not yet installed, and so we can't play it this way. And so in order to install our v6, instead of using devenv, we're going to use the v6 installer. And as a first parameter, we're going to specify the v6 we want to install. And as a second parameter, we're going to again use the root suffix and the domain in which we're working, which is currently analyzer. So let's give that a shot. And so now it found the file. However, it gives us an error because we're only restricting it to install on version 15. So let's first correct that. And so now I've modified my manifest. I specified I want it to run for the community, the Pro and the Enterprise version, and from version 15 till version 18. So let's rebuild and let's retry our command line. And so this time our v6 installer is doing its job. And so now it found Visual Studio Enterprise. Let's install. And so now we've installed our extension in Visual Studio. And so the next step is to reopen our Visual Studio with the root suffix analyzer. We take our dummy test project, and if we now go to extensions and we go to installed, we can see that our analyzer is installed. However, if we go to dependencies, analyzers here, it doesn't really show up. If we go into the class, we do see that the analyzer is working. If we click on the light bulb, we can have it fixed. So this way we prove that even by using a v6 analyzer, we can have our analyzers work. However, frankly, from my point of view, unless you really have an analyzer that you want to run on everything, this is not the way to go. But it's possible. So we went through the v6 installer and the NuGet package. These are options that are viable once you have a final product. However, if you want to first debug it, that's not really a viable option. So in order to debug it, we'll rather use the DLLs directly in our test project. So I've cleaned up my analyzer root suffix project to get rid of my v6 extension. And so I have again a clean test project. So now before modifying our root suffix analyzer, Visual Studio, we first need to tweak some of those settings in order to be able to debug better. So the first thing in order to be able to debug correctly in our root suffix analyzer, Visual Studio, is to change the settings. So we go to Tools, Options, we go to Text Editor, C# and Advanced. And there, on your normal Visual Studio, and in general, you want to have the code analysis to be running in its own process. However, here we want to be able to debug it. And so we need to deactivate this option and restart Visual Studio. And so we restarted it. Now the next step is we need to modify our project file and include an analyzer. And so I've copied the root directory, and the first library is our analyzer, and the second library is our code fixer. and that's the only modification for it to work directly with our debug libraries. And after having changed the project file, if we now look into debug analyzers, we can see it found our analyzer and our first analyzer 1. If we now go to the class 1 again, we have the warning, type class name contains lower letters, and we have the option to make to upper, and it works. So we have a working version directly linked to our debug version. Next, we need to attach our current Visual Studio to be able to debug it. So let's do that. Let's go back to the first Visual Studio. We're still running the same version. Let's go to debug. Let's click on attach processes. Let's filter on devenv. And as you can see, we have our analyzer test library and we have our current Visual Studio. And so this Visual Studio will attach to the second Visual Studio. We select that, we click attach, and we should be able to debug it. Now let's go to our analyzer class and let's put a breakpoint. And since we immediately have a red dot, we can see that the code is working and can be breakpoint. If you go back to our experimental version and we now rebuild, as we can see, the code enters in debug. We have a context and we can debug step by step what is needed. And so we have our symbol analysis context. We have our name symbol, which is our class. If we go into debug, we can see we have our analyzer class 1. And so our class 1, for each character, it verifies if it's lower and it isn't. So it creates a diagnostic rule and we have a warning. So now let's remove the analyzer and let's put some breakpoints in the code fix provider. Let's put a breakpoint here. Let's go back to the other Visual Studio. And if I now click on my light bulb, immediately it comes in and it will fix. And so now we can debug the fix provider. Now every time we make a modification in our source code, what we need to do is we need to close our analyzer root suffix Visual Studio. We need to rebuild and we need to restart again through the command prompt and reopen. This sometimes can be cumbersome, but that's the only way to be sure that we have the right code, and otherwise debugging and breakpointing won't work. So until now, I've been working on the base code generated by the wizard from the Analyzers project. This was mainly to show you guys how it's working and what were the different subcomponents which were created out of the box. So in the default project we had packages and v6, and I showed you how they both worked. Now I have created more elaborate code with analyzers and code fixers for 3 separate subdomains. One to handle test code, a second to handle web code, and a third to handle data code. As you can see as well, I've changed the file system structure because I didn't really like the dots in the subdirectories and the namespaces. And I've taken a more flat approach. I have an analyzer directory, I have a code fixes directory, I have a packages directory, and I have a test directory. But that's not a requirement. I've also introduced a namespace, Samayas tools code analyzers. However, since this sample code, for now, I've just created one project which contains and my data, and my tests, and my web, and whatever other analyzers I have. If you really want to work this through, you do have to create different analyzers and code fixes specifically for each type of project. Now, of course, the separation between web and test is quite obvious. If you create your real web project, a test project is separate from the web project. And performance reasons, even though those analyzers won't hit, they will still run. And so it's a good idea to have an analyzer specifically for test and another analyzer specifically for web, since they always work in the back and of course consume CPU cycles. Now, if you create your web project and everything which is web related, and your data and your model and your view models, or you create separate libraries for each of those subtypes, that's up to you. But having separate code analyzers still allows you to modularly add or remove those if you need them. Now, compared to the previous out-of-the-box project, I've also upgraded everything to the latest version, NuGet-wise, and I have no updates anymore. I've updated my test package to .NET 9, which at this time is the current version. And when updating to the latest version, a requirement that is or was added is that you need to have 2 separate extra files. Analyzers released and shipped, and analyzers.released unshipped. Since I don't have any analyzers here which are not shipped, those are empty. However, in this analyzer, I have 4 shipped analyzers, and I have documented them according to the guidelines. So I have 2 data analyzers, I have a web analyzer, and I have a test analyzer. I also try to create some naming style where each of those analyzers tries to clearly identify what it's doing. So I have a data class, suffix entity analyzer, for base class, entity base class analyzer. So let's dig into the first one. The goal here is to verify that if we have a class which inherits from a base class called entity base, then my class should end with entity. And so if we look a little bit in detail, the first thing what we do is we define a rule for that class where we have an ID, which I called sum.data01. It has a category of naming, and then I have a number of extra attributes which I've put in my resource file. And so as we can see, for each of those rules and for each of those classes, we have 3 rules. So if I inherit entity base, my class must end by entity. That's the title which is displayed. Then we have the message format, which is displayed somewhere, and then we have the description. And that's the same for all of my analyzers. Now each of the 4 analyzers implements by default the agnostic analyzer. I have my default constructor, which is needed or not. I have my supported diagnostic, which is an override, which implements the rule. And then I have my analyze function, which defines what I'm doing. And here I'm working on symbol kind name, which is my class. And then I have 2 private functions. The first is I check if my kind is of type class. Next, I check whether or not that class or a subclass inherits from entity base. And if that's the case, I verify that my class name ends with entity. And if it's not the case, I throw a report diagnostic. Then I have my test class, which also works on the class name, and I have my web class, which also works on a class name. If we go to web class, here I verify almost in exactly the same way that the suffix of my class name is viewModel for anything that inherits from base viewModel. So the code is almost exactly the same. If you really would want to, you could create base code from that and have those 2 analyzers use the exact base code with some extra parameters. For simplicity, I have not done this, but here again, I've defined my rule, I did my override, I initialized it, and my private function verifies whether it's a class, if it inherits from a base viewModel, and if it does, whether or not it ends with viewModel. The third one, test class attribute exclude from code coverage for base test analyzer, is almost the same. With the exception that here I'm not going to look whether or not the class ends with test, but I'm going to verify whether or not there's an attribute exclude from code coverage on top of the class if that class inherits from base test class, so that my code coverage analyzers skips all my test classes. And so here it's almost the same. And first we define the rule with the diagnostic ID, with the category, with the 3 variables specified in our resource file. We have our override support diagnostics, we have our initialize, and then we have our private analyze class, which verifies whether or not it inherits from base class, whether or not it has an attribute, and if not, it emits a diagnostic. And finally, we have our data method empty constructor for base entity classes. It's almost the same as the previous ones. It's still working on class. However, I still verify whether or not I inherit from entity base. If I do, I go on the class and I verify whether I have any constructors with empty parameters. And if I don't, I still generate a diagnostic. If I do, everything is okay. So let's test this out. I still start my Visual Studio with my root suffix analyzer, and I've created a new test project, pretty basic. And now here I've created separation. I have a test project and I have a simple class library, which could be a class library or could also be a website. For simplicity, I've just left it at that. Again, for debugging purposes, if I open the CSproj file, I've hard-coded my analyzers, but later if those analyzers are done and put it in NuGet package, you would just add your NuGet package. I've done the same thing for my test CSproj, and I also have my analyzers. Now let's first look at the test project. I've created 2 classes. I have my base test class. For simplicity here, it's just empty. In your real life situation, your base test class might have a number of functions which you would like to be reusing or initializers, which would be used in other tests. And then next, I have my first test. I have a simple test method, and I just have my base test class. So now if I look at my test 1, I have a rule that specifies if my test 1 inherits from base test class, it should be excluded from code coverage. So if I go and look at the rule sum test01, so my class test1 inherits from base test class and must be decorated with exclude from code coverage. So I have my first rule which is hitting. If I go to my view models, I have created a base view model with nothing in. I have created a number of subdomains. I have domain 1 view model which inherits from base view model. I have my domain 2 view model which inherits from base view model. And then I have my page 1 view model which inherits from my domain 1 view model to show that you have recursivity, and still my rule hits because I've called it view D model and not view model. And so the first rule, sum web01, class base 1 class page 1 view D model inherits from base view model and must end with view model. So again, my rule with multiple inheritance works. If I go to my page view 3 in my domain 2, there it's correct, and so it's not hitting. If I change it, it immediately hits as well. And finally, in the data, I have created an entity base class, which is an entity of type T, which might be an integer or a string if you want to implement that. I have my entity, which inherits from entity base of type integer. And again, it hits because I have a constructor int a, but I don't have a default constructor. And here again, if we float over it, well, I actually have two issues because I have two rules specified. The first is sum01, the class myEndDT inherits from entity base and must end with entity because I inserted a D in the word entity. The second rule, sumDate02, class myMDEntity inherits from entity base and must have a parameterless constructor. So all of my analyzers hit, which is good. Now let's have a look at my code fixes. So if I look at my code fixers, again, the project first references my analyzers. I have created again 3 subdirectories, data, test, and web. I have again my code fix resource, and for each of those fixes I have 2 keys. I have a key which is technical ID, and I have a title which will be shown if you click on the yellow bulb. Now let's have a look at our first test code fixer. As you can see here, we have an attribute which references itself. We have a fix diagnostic ID, which references the analyzer diagnostic ID, which we specified in an analyzer class. I have a default override get fix all providers. I have my register code fixers, and here in essence I retrieve everything so that I have the right object. I retrieve my class, and then once I got my class and my root object, I call an add attribute where I have 2 scenarios. I might have existing docs, which is my comment summary, or I might not. And depending on that, I might have already existing attributes. I will loop through and I will add, if it's not there, my existing analyzer. And I will add, if it's not there, my attribute exclude from code coverage. This class is quite extensive to try to cover all scenarios and to add the necessary field. The second and the third code fixer, web class suffix view model for base view model class fix provider, and data class suffix entity for base entity class fix provider are almost the same, and again might use a base class for fixing it. Again, it's the same thing. We inherit from code fix provider, we reference the class itself, the fix diagnostic ID reference the analysis ID, we specify an override on our get fix all provider, we have an override on registered code fix async, retrieve all the necessary properties, and then we register the code fix. And here it's quite simple. Once we have the class name, we just add view model, we call a rename symbol async, and that's it. And that's more or less the same thing for the data class as well. Now in this scenario, I have added all my code fixes and analyzers in the same project. However, in real life, I have created separate analyzers for each subtype. And the thing which I have not tried is to add a separate shared library between my different analyzers. So I don't know how that would work. In this sample, it seems easy to use a shared class. However, that might be more complicated when you need to distribute your analyzer, your code fixer, and potentially shared third DLL. I have no experience with that and I haven't tried it. It might work, it might not work. My guess is that the best approach in that scenario would be to create your shared library in another library, create a NuGet package from that, and have this NuGet package reference the other shared NuGet package. And that way, NuGet would make sure that those libraries are added in the right position. And then, by supposition, but I don't know, that shared NuGet package should probably also add the analyzers in this location. But I just don't know. I have not tried that scenario. And then we have a final code fixer, which is my method empty constructor. Again, we inherit from code fix provider. I have my fix diagnostic ID. I reference my data method analyzer. I do an override on getFixAllProviders. I do an override on my register code. Once I retrieve all my basic objects, my class object, etc., I just call my addParameterLess constructor. I define a constructor declaration, which is empty. And again, I call. And then finally, I update the document, which is my class. And finally, I return back to my tester. And let's first go to test and let's call the bulb, and it calls my exclude from code coverage. And my problem is fixed. Now let's go to my page 1 view model. Unfortunately in here, my code fixer cannot detect that view D model is a typo and should be view model. And so by simplicity, it will just add view model at the end, which is syntactically correct since the warning is gone, but which is not something that you might want. If you have just created page 1, adding view model is perfect. However, if you have made a typo, it won't necessarily show. But you will have other warnings showing that view D model is not really a known word. Now if we go to my entity, it's the same thing. It won't detect that the entity has a typo. It will just add entity at the end. Your rule is done, but the fix is not 100%. So let's first refix the name again. And now I have only the second rule, which asks me to have a default constructor. And here I insert my default constructor and my two rules are fixed. And so these are quite basic analyzers and code fixes. However, the sky is the limit. If you dig a little bit deeper, there are plenty of other examples with what you can do, what you can analyze, whether or not you have analyzers with code fixes or more complex analyzers that do show an issue, but that you can't really fix out of the box. And then finally, if you're serious about any of your projects, every project you do needs to have unit tests. Why? To test your code, to see in the future if you made some modification that everything you thought that was working is still working. So if we go back to the initial project, even there our base unit test already had a unit test. Now our initial project was in .NET Core 3.1 and was using a little bit outdated NuGet packages. My new test project, I've converted it to a .NET Core 9 application. I've updated all the packages. However, some objects have become obsolete. For instance, some of the verifiers. As a sample, in my new project, I had to change to default verifier, where in the original project, it was called MS-test verifier. Also, the original project contained a number of Visual Basic analyzers, which in my scenario I won't be using, and so I thrown them out. So my test project references my analyzer and my code fixer. I've created again 3 subdirectories, one for data, one for test, and one for web. So let's first look at the web analyzer. In there, as with the original one, I have 3 tests. My first test is a class analyzer success. And so in my scenario for that, I have created 2 tests. The first test, I have my base view model, and I have my view model that inherits from my base view model. The second one, to test my while loop, I have my base view model, I have a subview model, and I have my to view model that inherits from my subview model. And every time I call verify analyzer and it just succeeds. If it fails, that means that your verifier is not working. The second test is the analyzer failed. And here the goal is to make it fail and to see that if your class is not okay, that you have a failure, on what line you will have a failure, and whether or not that failure is correct. And so here again, I have my base view model. I inherit from my base view model. However, my class is this is and not this is view model. And here the debugging becomes a little bit more tricky. I have to specify a debug result, where again I call my CS verifier, which is some of the helper classes. And I also have to assert on what line, my start column, my end column, and with what argument it's gonna fail. So let's run this test. And of course, as you can see here, the test run correctly because I've already filled in everything correctly. So if it is correct, you will just see a green sign. Let's run this one again. And of course, you don't see any details. The trick is finding out what are the arguments you need exactly. And for that, the verifier is helping you. Let's say I make a mistake and I put in 18 and I change this, and let's run the test again. I know that my test is gonna fail, but I don't know what the width span or the width arguments are which I need. And here the test is quite helpful because my start line is 18 and my end line is 8. And it already complains that, well, I cannot start after I ended. So that's the first error. Let's make that 20. At least the first error will be gone, but it's not the right values anymore. So let's try again. I still fail. And here the error is more clear. I was expected to be looking for 18 25, 20, 31, but I need 8, 25, 8, 31. And here your verifier will just tell you what are the variables you need for the test to succeed or to fail, so to speak. So I'll undo this. So I now put the right width span, but I just put the wrong width argument and it will still fail and it will still show you what is wrong. And so you can see that the width span here and here are okay, but that the width argument is not okay. So if I remove again the extra D and I run the test again, I come again to result. However, debugging and working like this is quite cumbersome. Now, of course, if I want to test my analyzer, I can just go to my analyzer, I put a breakpoint here and I run my test in debug. And at some point it comes into the analyzer. And then finally, I have a test for my fix provider. And here again, depending on the scenario, you might have one or more possibilities. I've just put a simple one. I have my base view model. I have my class, which is called myView2. And in this scenario, the expected result would be myView2 view model. So here you have your initial code and here you have your expected code. Again, the arguments are the same as with the analyzer because the arguments are the one which are coming from the analyzer. And based on that information, if you're wrong again, let's say I put 9 and I run this test, it will again show you what is wrong and how you need to correct. I put 5. And again, it shows you that you put in 5, 18, 8, 25, and you need to put in 8, 18, 8, 25. So in essence, the CS verifier class, and you have 3 of them here, 4. Basically you have 2 parser classes. You have the analyzer verifier, you have the code fix verifier, you have the code refactoring, which I haven't used, and you have a helper class. And so how does this work? At the beginning of your file, you need to define your CS verifier, which is using your code fix verifier, and you need to specify your analyzer and your code fixer. However, there's a kind of twist. For web, at this point, I've just defined my custom base view model. Now let's have a look at our test verifier. And here it becomes a little bit more complicated. We have an attribute, exclude from code coverage, and that attribute has a namespace system diagnostic code analyzers. If I go back to my test project, and I go look in there, it's using system runtime DLL. And so somehow I need to include that in my verifier. And that's where, compared to the original code, I needed to add extra packages. And so I've added reference assemblies, which allows my code to compile and to test. And so in this scenario, I've added system runtime and I've added the MS test framework. Depending on how you have your code and add extra packages to test just that code, you might need to add those assemblies at other location. For this verifiers, currently, I'm just using the code fix verifier. However, you also have the analyze verifier with just test analyzer should you have an analyzer without code fixer. And there you need to add it as well. And you might have refactoring verifier with just test refactor. And here you might need to add it as well. And then finally, I have 2 data fixer testers. And here again, I have my analyzer which tests that my entity inheriting from entity base ends with entity. The second one had an extra D and so it will fail. And the code fixer just transforms my to my entity. The same for method data empty constructor. I have the one with an empty constructor, or rather I haven't specified a constructor, so that's still an empty constructor. I have the second where I have specified a constructor without an empty and that will fail. And I have my code fixer where I just have a default constructor and the end result should be my entity. Now, throughout playing around with it, using the test verifiers in essence to validate that the code doesn't change is a good thing. However, I found it quite cumbersome to work with that and try to use that in the first place just to write my code. And so I preferred debugging and playing around with my Visual Studio until I get the right result. And once I had my code fixer and my analyzer working, only at that point was I writing my unit tests. On a lot of other projects, I first start by writing my unit tests. But in this scenario, it seems more cumbersome. So even though, at first sight, Roslyn seems like very nice, all looks fine, but not everything is fine. Throughout my personal exploration of Roslyn, I've also introduced some analyzers where I want a specific format for my summary text on top of my unit tests. And even though in my Visual Studio I don't have any warning anymore because I fixed it, when I built my project for a specific type of test, I still have 300 warnings. And only by double clicking on it, that fixes it. And I've lost a hell of a lot of time trying to get rid of that issue and trying to determine what exactly the issue is. So initially the text I displayed was method for my method, should be of a specific text, but is of empty. Now, as you can see, on top of this method, I clearly have my correct text, yet it's still displaying a warning. After a lot of searching on the internet, the first fix what I found was to go to my Tools, Options, and in my text editor C# Advanced, change my background code analysis from current document to the entire solution. By implementing that, somehow all those errors are gone. So at first sight, this may sound as a perfect solution. However, that means that my computer and Visual Studio is running analysis all the time on all my files. If you have a small project, that's okay. If you have a large project, that takes up CPU cycles for nothing. Now, even though the errors are gone now in my error list, if I go back to the output window, they are still there. And so even though if I rebuild, the warning still keeps showing up. So my initial message for my warning was that the summary should be looking like that. So in the end, I started to add extra debugging to see why it was failing. Because in the end, I was just comparing a string, which I would like it to be, with the string on top. And so I discovered the hard way that when you run Roslyn in Visual Studio, or when Roslyn is run through the build process, it doesn't access the same information. After a lot of tweaking and a lot of searching, in the end, for my test project, I found a solution. And so what I needed to change was to enable documentation on top of my text project, which means it generates an XML file which you can use for documentation. And after inserting that one, suddenly Roslyn with the build process with .NET Build had access to that information and all those warnings were gone. And so now even if I revert in my options for my entire solution to just my current document, nothing shows up anymore. Now this kind of behavior, I only had it on comments, not on other code. So again, it depends what kind of analyzers you make. So do we absolutely need this? Of course not. But then again, if you're in IT, as a developer, the cleaner the code, the less risk of bugs. The more we impose standards, the easier it becomes to understand and to keep clean. In essence, it's like keeping your house clean. Once you understand the system, it's quite easy to implement. However, I still run into quite some issues. I've mainly experimented with class names, class attributes, class comments, method names, method attributes, and method comments. For comments, Roslyn uses trivia to handle summary comments and attributes. And even a simple modification of an existing structure is sometimes more complex than adding something that is missing. There are some hidden formatting happening sometimes, and cleaning it up makes it more complicated. In one instance, it was easier to finally modify the text on a method rather than handling the trivia objects, since I either ended up with an extra blank line or extra tabs and a formatting disaster. Also, I do have issues that sometimes I see the warnings in the output windows but not anymore in the error list. However, I have my own framework and code going back at least 1 year. And even with the hiccups, just on testing code, after implementing some styling, I started with roughly 6,000 warnings that needed to be fixed or aligned. So in the end, it seems worth it for me, even with the quirks there are. My code is now cleaner and more aligned with my quote-unquote self-imposed style. If you guys like this content, give it a thumbs up, subscribe to this channel and hit the bell sign. Or leave a comment down below.